Hello, everybody. All right, so in today's lesson, we're going to be talking about problem solving, compare volumes. We're on lesson 11.10 of the fifth grade Go Math textbook, and we're on page 503. And so, our essential question is how can you use this strategy, make a table to compare different rectangular prisms with the same volume? Okay, so unlock the problem. Adam has 50 1-inch cubes. The cubes measure 1 inch on each edge. Adam wonders how many rectangular prisms, each with a different size base, that he could make with all of the 1-inch cubes. So basically, we need to find all the different ways of making a base and height of 50. Okay, we need a volume of 50 cubic inches. All right, so what do I need to find? I need to find the number of rectangular prisms, each with a different size base, that have a volume of 50 cubic inches. Okay, so that's our goal. How many different ways can we find it? What information do I can use the formula volume equals length times width times height, or volume equals base times height, and the factors of 50. Okay, because we need to have it multiply and have a product of 50 for the volume. So what can we do? I'll use the formula and the factors of 50 in a table that shows all of the possible combinations of dimensions with a volume of 50 cubic inches without repeating the dimensions of the bases. All right, so what are the different ways of making 50, right? So if we were making a list of the factors of 50, well, I know 1 times 50 is one possibility, right? I know 2 times 25 would be an option. I know 5 times 10 would be an option. And then I could also use the commutative property for those and just switch these around. So if I said the base was going to be 1, the height would have to be 50. But I could also have a base of 50 and a height of 1. So that's our challenge here, is we have to find the different ways of using these numbers as base and as height. Okay, so let's see what they've got here. They've got 1 times 50. All right, that's the 1 times 50, right? All right, then they have 1 times 2 as the base and a height of 25. Again, that's this one, 2 times 25. 5 times 1 times 10. So those are the three possibilities I've listed. Those are the factors of 50. But we can switch it around, right? I could say 50 times 1 as the base. I could say 25 times 2. And I could also say 10 times 5. Well, okay, so if we do 10 times 5, isn't that 1 times 10 times 5? Sure. 1 times 25 times 2? 1 times 50 times 1? But then we get into a little trickier situation. Can I have a base that's not 1 times 50, but still have a volume of 50? Or I mean an area of 50? Sure. So for instance, on 10, 1 times 10 is 10, but is there another way of making 10? Or to have a base of 10? Yeah, 2 times 5. So 2 times 5 with a height of 5. Well, that would be 50. All right, so that's the only ways of making 10, right? 1 times 10 or 2 times 5. How about 25? We know it could be 1 times 25, but couldn't I use 5 times 5? Okay, 5 times 5 times 2. Okay, so we have 1 times 25 times 2, and we have 5 times 5 times 2. Right, how about 50? Well, we have 1 times 50. Could I use 2 times 25? Of course. And if I did 2 times 25, that would be a height of 1. Because 2 times 25 is 50, 50 times 1. All right. And what about 5 times 10? Times 1. So in other words, what are the different ways of making 50? Well, we have 50 times 1, we have 2 times 25, and 5 times 10. All right. So, okay. So what else do you need to solve the problem? Well, don't have to count up all the different possibilities. So, all right. So I need to count the number of rectangular prisms that can be made from 51-inch cubes. Well, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different ways. So all we did was think of all the different ways I could have a volume of 50 using the different factors of 1 and 50, 2 and 25, and 5 and 10. All right, let's try another one. Let's go to page 504. All right, so Mrs. Wilton is planning a rectangular flower box for her front window. She wants the flower box to hold exactly 16 cubic feet of soil. How many different boxes, all with whole number dimensions and a different size base, will hold exactly 16 cubic feet? So same idea, except this time we're using 16. So what do I need to find? I need to find how many different rectangular boxes. All right. So basically the question, right? How many different size bases or rectangular boxes with a different base can you hold that can hold 16 cubic feet of soil? We need to find all the different possibilities. What information do I need? Well, just like in the last one, we need to know that the shapes are rectangular prisms. I need to know the formula for volume. V equals length times width times height, or base times height. Okay. And how will I use this information? I'm going to put the information in a table. So I will use the volume formula. And the factors of 16. To complete a table. Okay. So use the volume formula and the factors of 16 this time to complete a table of possibilities. So what did our table look like on the other one? Well, we had a base, right? And we know that that's length times width. And we had a height. And then we put it together with the volume formula. Okay, so let's make some factors of 16 just to get started. Oh, we know 1 times 16. That definitely works. I know 2 is a factor of 16. So I know I could have 2 times 8. I know 4 times 4 is 16. So those are the 3 basic ones. So I could say that those are the base and these are the heights. But I can also switch them around, right? So I could have a base of 16 and a height of 1. I could have a base of 8 and a height of 2. And 6, 4, and 4, that's going to be the same thing. So there's really no changing that around. Okay, so let's go ahead and start with the basic one, 1. If the base is 1, the only way to make 1 is 1 times 1. And so if the base is 1, the height must be 16. So 1 times 1 times 16 equals 16. Right? So that's one possibility. Let's go to the next one. If we have a base of 2, well, we know the only way to make 2 is 2 times 1, which means the height must be 8. So 2 times 1 times 8 is 16. Now let's go to 4. 4 is kind of interesting. We know 1 times 4 would work. And 1 times 4 then would be 4. 4 is the height, because 4 times 1 is 4. 4 times 4 is 16. But there's another way we can make 4, right? Sure, 2 times 2. So if 2 times 2 is 4, we also have a height of 4. So 2 times 2 times 4 would also be 16. All right, well, now let's look at these. 16. Well, I already know that I can have 1 times 16. So if the base is 16, I could say 1 times 16, and that would mean the height's 1. Is there another way of making 16? Sure, 2 times 8. You notice that we don't have a base of 2 times 8 here. So 2 times 8 times 1. And we have 4 times 4. Well, we already did 4 times 4. Right? There's no other way of making a base of 4. Okay. So we have all the possibilities of 16 already. Now how about 8? What if I had a base of 8? Well, I could have 1 times 8 times 1. Okay. Is there any other ways of making 8? Yeah, 2 times 4. I got to change the height here to 2. 8 times 2 is 16, not 8 times 1. 8 times 2 is 16. 4 times 2 is 8. 8 times 2 is 16. Is there any other ways of making 8 using 2 factors? No, there's not. So how many different ways did we come up with? 1, 2, 3, 4, 5, 6, 7, 8. Okay, and let's double check our numbers. Okay, 1 times 1, 1 times 2, 1 times 4, 16 times 1. Oh, I left off an easy one. We were doing 16, right? And I said 1 times 16 and 2 times 8, but I didn't put 4 times 4 as the base. So I can still use 4 times 4 as the base because I didn't use it. Okay. All right. So we have 9 different ways. All right, let's look at page 505. Number 1. A company makes concrete paving stones in different sizes. Each stone has a volume of 360 cubic inches and a height of 3 inches. The stones have different lengths and widths, but no stone can have a length of 1 or 2. No stones can have a length of 1 or 2. How many different paving stones, each with a different size base, have a volume of 360? All right, so think about what the problem is asking us to solve. We have to find the different size bases that will give us a volume of 360. We're going to make a table, same as we did on the other ones. We're going to have a base, we're going to have height, and then we'll have the volume. Okay. Now there are some restrictions though in this problem. Okay. So it has to have a height of 3. So let's find out what the base has to be then. So if we have a height of 3 and we divide 360 by 3, that'll tell me what the width and length has to the area of the width and length, or the base has to be. So 120. So we need to come up with the factors for 120. Well, we know 1 can be 1 times 120, but then it said that they can't have a width of 1 or 2. So right now we're just going to list all the different possibilities for 120. All right, 120, I could also have 2 times 60. I could have 3 times 40. I could have 5 times 24. 6 will work because 2 and 3 are factors, so 6 times 20. 8 will work. 8 times 15. And 10 times 12. All right, so we know the base has to be 3. Okay. So, I'm sorry, the height has to be 3. And I can't use 1 or 2. So I can eliminate that possibility and that possibility. Okay. Because I can't have a dimension of 1 or 2. All right, so let's start with 3 times 40. All right, so 3 times 40 times 3 is 360. Let's go to the next one. 5 times 24 times 3. 6 times 20 times 3. 8 times 15. 10 times 12. Okay, let's see if we've missed any. We did have one factor missing. Hopefully you recognized it. I left out 4. I should have 4 times 30. Because if 3 times 4 tens is 120, then 4 times 3 tens is 120. So let's put in that one. 4 times 30 times 3. All right. So those are all the possibilities of making 120 as the base, excluding 120 times 1 and 60 times 2. So how many different possibilities do we have? Well, we have 2, 4, 6 different paving stones. Okay. Right now, number 2. What if the 360 cubic inch paving stones are 4 inches thick and any whole number length and width are possible? How many different paving stones could be made? All right. So we're still taking the same idea, but this time we're going to start with a height of 4. Okay. All right, so 360 divide by 4. That's going to tell me what the base is. 9 times 4 is 36. So 90. So I need a base of 90. Well, 1 times 90, right? 2 times 45. 3 times 30. Will 4 work? Don't think so. No. Okay. 4 times 22 is 88. That's the closest you can get. We know 5 will work because it ends in a 0. That's going to be 18. Okay. Since 2 and 3 work, we know 6 will work, and that's 6 times 15. What else? 7? No. Closest I can get with 7 is 7 times 12, 84, or 7 times 13, which is 91, so no. 8? No. Closest I can get to something that multiply by 8. 8 times 12 is 96. 9 works for sure. 9 times 10. And then 10 times 9. So now we're starting to repeat. We're just going the opposite way. So it looks like we have 6 different ways again. So we have 1 times 90. We have 2 times 45 times 4. 3 times 30 times 4. 5 times 18 times 4. 6 times 15. And finally 9 times 10. So what we were doing in this problem was simply trying to find all the different bases I could make using 90, using a product of 90, because they told us the height had to be 4. So all the bases have to have a product of 90. Okay, so how many different paving stones could be made? 6 stones. Now, suppose that the cost of the paving stone is $2.50 plus 18 cents for every 4 cubic inches. Well, if the volume's 360, and we divide by 4, we'd have to multiply 18 cents times 90. So, so 18 times 90. Okay, well, order of operations says multiply first, so let's do that. 90 times 18. We get $16.20 plus $2.50 will give us 50 and 20 is 70, and 16 and 2 is 18. So it would have a cost of $18.70. So what do? The paving stone has cost is $2.50 plus 18 cents for every 4 cubic inches. We know the volume of one stone is 360. So how many 4s are in 360? 90. So we're going to multiply 18 times 90. All right, number 3. One company makes inflatable swimming pools that come in 4 sizes of rectangular prisms. The length of each pool is twice the width and twice the depth. The depth of the pools are each a whole number from 2 to 5. If the pools are filled all the way to the top, what is the volume of each pool? Okay, so when we refer to depth, that's the same thing as saying the height of something. Okay, so it would, remember, volume is going to be length times width times height. Well, in this case, we can substitute the depth for the height. So they said that the depth goes from 2 to 5. Now it said that the length is twice the depth. Well, twice 2 is 4, twice 3 is 6, twice 4 is 8, twice 5 is 10. So the length is twice the width and twice the depth. All right, so the length is also twice the width. Okay, so what's the volumes? Four times 4 is 16. 9 times 6 is 54. 32 times 4 is 128. And 25 times 10 is 250. Okay. So our volumes are 16 cubic feet, 54 cubic feet, 128 cubic feet, 250 cubic feet. Okay. So remember, the directions told us that the length was twice the width and depth of the pool. If the depth is 2, the length has to be 4. And so if the length is twice as much as the width, then basically it's 4 divided by 2, 6 divided by 2, 8 divided by 2, 10 divided by 5, 10 divided by 2. All right. Now let's look at page 506. Number 4. Ray wants to buy the larger of 2 aquariums. One aquarium has a base that is 20 inches by 20 inches and has a height of 18. So if we're looking at this one, base times height, so the base of his is 20 times 20 times 18. Okay, so that's one aquarium. The other aquarium has a base that is 40 by 12 and a height of 12. So the other one is 40 times 12 times a height of 12. Okay. And so which aquarium has a greater volume? And then by how much? All right. So first we just want to find out which one has the larger volume. Well, 20 times 20, that's 400. And 18 times 4 hundredths. Well, that's 7,200. All right, so this one is 7,200 cubic inches. And now how about this one? 12 times 4 tenths is 48 tenths. So 480 times 12. 480 times 12 is 5,760 cubic inches. So the aquarium with dimensions 20 times 20 times 18 is greatest. And by how much? We just have to subtract these two. So 7,200 minus 5,760, 1,440 1,440 cubic inches more. Okay. All right, Mr. Rodriguez works at a store. He wants to arrange 12 toys in a display shaped like a rectangular prism. The toys are in cube-shaped boxes. Okay, 12 toys. How many rectangular prisms can he make? Well, this sounds like our the problems we've been doing, right? Where we're going to have a base, we'll have a height, we'll have the volume. So we have 12 toys. What are the different ways of making, what are the factors of 12? 1 times 12, 2 times 6, 3 times 4. All right, well, let's start there with those. So we could have a base of 1 by 1 and a height of 12. So 1 times 12. We said that we could have 2 times 6 times 12. I'm sorry, not 2 times 6 times 12. 2 times 6 times 1, because 2 times 6 is 12. We could have a base of 3 times 4 times 1, which is 12. All right, so those are possibilities for bases, right? Is there a different way of making 6? Sure, 2 times 3, right? So 2 times 3 is 6, and 6 times 2 is 12. All right. So we've already figured out that 2 times 6 times 1 is 12. Could I have a base of 2 and a height of 6? Sure. So what's the way of making 2? 1 times 2, and then a height of 6. All right. Is there a way of making a base of 6 other than 2 times 3? Yeah, 1 times 6. All right, so we've got 6 times 2. We've gotten all the possibilities for 6 times 2. Okay, we did 2 times 3, which is 6 times 2. We did 1 times 2 times 6. And we've done 6 times 1 times 2. How about 3? Is there a way of making 3? Sure. 1 times 3 times 4 equals 12. That's the only possibility of making 3, right? But I can make the height 3, right? Change this to the height, and that means my base has to be 4. Well, I could have 1 times 4 times 3 is 12. I could have 2 times 2 times 3. Okay, so those are the different ways of making 4, right? There's only 2 possibilities for 4. We've done 6 times 2. Okay. Okay, let's double check to make sure we've got all of ours. So 2 times 6. So if I made the height 6, the only way of making base of 2 is 2 times 1. Okay. Base of 3 times 4. If I made the base 4, there's only 2 possibilities. If I make a base of 3, 1 times 3. A base of 4, 2 times 2, yeah. 2 times 1 times. Okay. So let me just double check my notes. So what if we only had a height of 1 and we had 1 times 12? That could be a possibility, right? Yeah. Okay, so those are the possibilities. So how many did we make? We made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 prisms. Okay. Rectangular prisms. Right, number 6. Marilyn has 4,000 1-inch cubes. She wants to pack them into a carton. The carton is 1 foot high and its base is 1 foot by 2 feet. Will all the cubes fit into the carton? Well, if we look at this, they have given us dimensions of 1 times 2 times 1, but those are in feet. All right, so she has inch cubes, so we need to change all of these feet into inches. So 1 foot, that would be 12 inches. 2 feet, 24 inches. And 1 foot again is 12 inches. All right, well, 12 times 12, if I switch that around and go 12 times 12 times 24, I'd get 144 times 24. So what is 144 times 24? 16, 17, 5, 8, 8, 2. 3,456. So, no, that won't work. No. The container has a volume 3,456 cubic inches. 4,000 is larger than 3,456. And finally, number 7. Dakota's wading pool has a volume of 8,640 cubic inches, which could be the dimensions. All right. So multiplying those 3 together, do they come out to 8,640? 24 times 3 tens. 24 times 3 tens is 72 tens. So 720 times 12. $8,640. So A works. 27 times 32 times 10. Well, 32 times 10 is 320 times 27. 8,640. That works. 28 times 31 times 13. Well, I'm going to use reasoning on this one. 28 inches, that's longer than that. 31 inches, that's longer than that. 13 inches, that's longer than that. So if all three dimensions are longer than this one, the volume has to be more than 8,640. So that won't work. All right, now how about this one? Again, 30 inches is longer than 24. 37 is longer than 30. 18 is longer than 12. Again, all three dimensions of this one is larger than this. So it has to be larger than 8,640. So those two are not possible. Now, if you didn't want to use that, you would, of course, multiply 28 times 31 times 13. Okay, so that would be 868 times 13. 11,284. This bottom one, 18 times 3 tens is 540 tens times 37. 19,980. So again, both of those are going to be larger than the 8,640. Okay. All right. So that's it for today's lesson. We'll finish up the 5th grade Go Math textbook in our next lesson, where we talk about the volume of composite figures. So until then, I'll see you soon.